No. No student. Is it audible to all? Start within 5 minutes. Wait for few more students. If they will join, then we'll start. After that, we'll start. Hello. Just check it is audible or not. Hello. Hello. Is it audible now? Hello. Just check it now. Is it audible? Yes. Now is it check? Now check it. Okay, na? Is it okay? One minute. Okay, now is it okay? Check it now. Is it okay? Okay. So first of all, welcome to all of you to the question answer session. So today we'll discuss the another set, that is set 3. The first question is design a DFA for the language L equals to W such that where mod W is multiple of 3 and string starting with A, and inputs used here AB. Clear? So can you tell me what is the language we can write here? What is the language we can write here? Just tell me what is the language you will write. Anybody? So it is saying that W string is multiple of 3, right? Means the length of the string should be 3. And here in the string, length of the string should be 3. 1 minute. Yes. Triple A, AAB, ABB, ABA. So here the string, whatever the string it will form, it will contain a character either A or B, isn't it? And the length of the string, minimum length should be 3. Here the string may be triple A, ABA, okay, then ABB, clear, then A, AB, like this you can write the string, and AB, ABB, AB. Is it possible the BAB. Is it possible? It is not acceptable by the finite automata. Yes or no? By the language. Why? Because the number of characters present here 5. But as per the question, it is saying that string should be multiple of 3. Means 3, then 6, then 9, like this number of characters should be there. Clear? So if you draw the finite automata here, then you will get first take Q0. I will draw for the minimum string AAA. So take Q0, Q0A, this is Q1, okay, then Q1A, that is Q2, then Q2A, that is Q3, okay, and it should be your final state. Clear? Done. So always it should start with A, means you should always consume A on Q0 only. You cannot consume B on Q0. If you consume B on Q0, it should not move to the final state. So that's why, so it will take B transaction on Q0, then it should move to the QD. That is our dummy state, right? Dummy state. To satisfy this diagram as DFA, we should make a dummy state. Clear? Why we have not taken the B transaction on Q0 to move Q3? Because as per the question it is saying that the string always it will start with A only. Clear? Then, but after first A, you can consume either A or B. That's why on Q1, if you consume A, you can move to Q2. Similarly, if you consume B also, you can move to Q2. Because there is no restriction on second character. Similarly, there is no restriction on third character also. I hope everybody understood. Done. So Q1 consumed both AB, Q2 consumed both AB. Now we will make Q3. So by consuming Q3, we can come to Q1 state. So that is also AB. Yes, wait 1 minute. Hello. Now take it. Hello. Is it coming now? Is it coming now? ठीक ठाक तो है। देखो अभी देखो। हेलो। 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 यस मैं तो बोल रहा हूँ। हेलो। हेलो। Oh, some network issue is there. That's why it is coming problem. Okay, ठीक है. So see here. 1 minute. Some glitch is there. Okay. So see, so in this question it is saying that, again I will repeat this question. The length of the string must be multiple of 3. Means minimum 3 characters should be there inside the string. Okay. So if you take the string as AA, then it is not acceptable. If you take the string as AA, that is not acceptable because here number of characters are 2, right? So all the strings you will form with 3 characters, then that is acceptable. So that's why I have taken the minimum string here AAA, and for AAA I designed the finite automata NFA. Clear? Then though it is saying that the first character should be A, it should start with A. Clear? So that's why, so on Q0 I consumed A, and by consuming A I move to Q1. So on Q0 you cannot consume B. If you consume B, then it should move to the non-final state. It should not come to the final state. So that's why, so on Q0 after consuming B, it is moving to the QD state, okay, dummy state. But there is no restriction on second character and third character or other characters. So that's why on Q1 you can consume either A or B. Clear? By consuming either A or B, you can move to Q2. Similarly on Q2, by consuming either A or B, you can move to the Q3, right? So now Q0, Q1, Q2, Q3 completed as per the rule of DFA because they all consumed both the inputs A and B. Now we'll consider Q3. So Q3, for example, let the string is ABBAB. Clear? So in this string, 5 characters are there. Though it is having 5 characters, hence it should not reach to the final state. Clear? So see here, this is A, then B, then B. Again after consuming A, then you will move to the Q1. Clear? Either consume A or B, you will move to the Q1. Then on Q1, if you consider another character, then this will consider as the 5th character, right? So when you will consider 5th character, when you will read the 5th character, it will reach at Q2, and Q2 is a non-final state. Clear? So I hope everybody understood. The string ABB, ABB, AB, similarly AB, A, then BA. Clear? Similarly A, B, 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 A. So all the strings will not satisfy. Why? Because all these 3 strings are consist of 5 characters. Okay. I hope everybody understood. So this is your DFA figure, final DFA figure. Clear? Then in the second part of the question, it is saying perform extended transition function for the following strings. Means you perform extended transition function on A, B, B,
and second is AB, AB, right? So what is extended transition function? In a normal transition function, remember, in a normal transition function, we will read a single character on a state, and by reading single character, we will move to a particular state. So the normal transition function maybe you can write delta q0 a equals to some state, okay? Some state you will move, you will reach, right? But as for the extended transition function, you should write delta star q0, then a string you need to read, clear? So for example, let you will read the string a b b, clear? So if you will read a string on a state, and by reading the string after means executing after means processing each and every character, so at last you will reach a particular state, clear? That is the meaning of extended transition function. So the difference between normal transition and extended transition is, in a normal transition you will read a single character at a time, but in extended transition you will read a string on a particular state, and by reading the string you need to reach another state, okay? So now we'll apply extended transition on ABB. So let's see here, delta star ABB, we'll write here delta star Q0 ABB, that we can write as delta of okay, then delta of q0 a comma b comma b, okay? That is the rule of extended transition. Now if you will see inside the finite automata, delta q0 a equal to how much? Delta q0 a equal to q1, right? So we can write that is q1, clear? So if you read now delta q1 of b, clear? So the whole transition result is what? Delta q1b, means on q1 if you read b, then where you are moving? q2 state, right? So we can write that is q2, clear? So total now you can read delta of q2, then the last character b. So if you read delta q2b, where you are moving? On q2, if you read b, then you are moving to q3. You are moving to q3, and q3 belongs to q, and it is a final state. It is a final state. Yes or no? So as for the means extended transition function, after reading the string, okay, on the initial state, if you are reaching at the final state, then the finite automata is acceptable. So it is not visible. I will write here q3. I will write in here q3 belongs to q, and it is a final state, clear? And as for the extended transition function, after reading a string on the initial state, then if you will reach at the final state, then that language is accepted by the finite automata, means ABB is acceptable. I hope everybody clear. Similarly, we will check the other language, that is AB, AB, AB. 1 minute, student. I hope it is clear. First question. So you just do the second part Q0, that is AB. Second part you do it. Second part, can anybody tell what you will get? What is the result you will get? Yes, not acceptable. Wait here, some problem is going on. Okay, second question you will complete now. So like here Q0 ABB, you will write there ABAB. Okay. In place of ABB, you will write here ABAB. Here ABAB. Okay. Just 1 minute here. Here it is going on slow. Okay. Come to the second question. Second question it is saying that consider the following epsilon NFA and convert it into DFA. So remember here you may get two different type of question. One is epsilon NFA to DFA, and second is epsilon NFA to NFA. Okay. So in both the question, first you need to calculate the epsilon closure. So here First we will calculate the epsilon closure, then I will tell you the difference between these two question processing. Okay. Here epsilon closure of P equals to how much? First initial the same state P, then to which state it is moving, that is Q and R, right? So go to the table and check P epsilon equal to QR, means epsilon closure of P equal to P, Q and R. Clear? Similarly, epsilon closure of Q equals to, we can write first Q, then from the table it is mentioning P, means though epsilon closure of Q equals to P also, and P epsilon closure is PQR, hence we can write the epsilon closure of Q equals to PQR, all three members. Okay, Q, P and R, all three members. Hope understood? P, Q and R. Clear? Similarly, epsilon closure of R equals to how much? That is first the same state R, and check from R to which state it is moving with consuming epsilon. There is no state, okay? Because R epsilon equals to 5. So hence R epsilon closure of R equals to R only. Hope it is clear to everyone. Now what we will do, come to the difference here. If epsilon NFA to DFA question given, if epsilon NFA to NFA question given, then what you will do? So you will calculate the epsilon closure transition on each and every state by consuming all the inputs. Clear? That means you will calculate delta dash Q0, sorry, PA, P, then A, then delta dash P, then B, then delta dash P, then C. Clear? Similarly, delta dash okay. So if the question is epsilon NFA to NFA, then you need to calculate the epsilon closure transition of each and every state by consuming all the input terminals. How many input terminals are used inside the finite automata? Hope it is clear. But if the question is asking epsilon NFA to DFA, then what you need to do? So you know that the initial state of NFA should be remain same also inside the DFA. Clear? That's why you will consider the epsilon closure of the initial state. What is the initial state here? P. Clear? So the initial state of P, that is combining PQR, right? So you will consider this combination of PQR as initial state of DFA. Hope everybody understood. So see, when you are processing epsilon NFA to DFA, at that time you should write epsilon closure of P equals to PQR. Clear? So this combination of three states, we will assume a state as A. Clear? Either you can write PQR combining one state, or you can assume that state as A. Means at the time of processing, what you will write? Delta dash, okay? Either you can write A of small a, or you can write delta dash, okay? Here you will write P, Q, R, combination of the state, and you will read A. Hope it is clear. both are same meaning. So if you write delta dash AA, its meaning is epsilon closure of delta of delta of okay A epsilon comma A. Clear? This is the rule. Similarly, if you write like this, the meaning is epsilon closure of okay delta of PQR okay combination of three state comma epsilon then comma A. Hope it is clear to everyone. So this is the method you need to follow when you require to convert a epsilon NFA to DFA. Clear? But when you will convert epsilon NFA to NFA, then these three state procedure you need to consider. Clear? Now one by one we will process. So first we will write epsilon closure of okay P equal to how much you got? You got PQR, right? P, Q and R. Clear? Let us consider this state is A state. Okay? Now we'll write epsilon closure of Q equals to how much? That is also PQR, right? Clear? Similarly, we can write epsilon closure of equals to how much? That is R. Clear? Now, in the next processing, we will write delta dash of A then small a. What will write? A small a equal to epsilon closure of epsilon closure of delta of delta of A epsilon then comma A. Yes? Now we'll find out. A epsilon means what? A means PQR, right? So we can write that part as epsilon closure of delta of delta of okay PQR then comma epsilon comma A. One minute student here. Okay. Is it audible now? Everything it is clear now? Is it clear to, is it clear to everyone how why I wrote like this? Yes. Then that we will write is epsilon closure of clear delta of PQR epsilon equal to how much? P epsilon, Q epsilon, R epsilon means P epsilon closure, Q epsilon closure and R epsilon closure. So what you will get? PQR only, right? So here you will get PQR only. PQR then comma A. Clear? Then that we can write epsilon closure of delta PQRA means delta PA, delta QA, delta RA. That we can write delta PA union of delta QA union of delta RA. Okay. So now delta epsilon closure of PA, QA, RA. Just go to the table and just check it. PA equal to how much? PA equals to 5, right? So we can write epsilon closure of 5 union QA equals to 5, PA equals to 5, QA equals to P and RA equals to 5. So that you will get epsilon closure of P that equals to PQR. Okay, na? Similarly, you will calculate delta dash AB. So, if you calculate delta dash AB also, you will get here up to here PQR you will get PQRB, right? So, directly we can write here delta dash AB equals to we will get epsilon closure of delta of PQR then B. Clear? So delta PQRB means what? P of B, Q of B and R of B. Clear? So P of B equal to how much? P of B that is Q and Q of B equal to R. R of B equal to 5 means you will get QR. So you will get here epsilon closure of that is QR. Yes? So epsilon closure of QR means what? Epsilon closure of Q union epsilon closure of R. Epsilon closure of Q equal to PQR and epsilon closure of R equal to R means you will get here PQR only. Clear? Similarly, if you do it for delta dash AC, same thing you will get PQR only. Clear? Delta dash, you just try it, delta dash AC equal to also you will get PQR only. Just try it. PQR means what? This is also A state, same A state, and this is also A state because already you have taken A, right? And this is also A state. Means there is no new state it produced. Clear? Only one state only it is producing, that is A. A is what? Combination of PQR. Means whenever you will design the DFA, so you will take only one state, that is PQR. PQR. So that is the one combination of state only. Okay. And though R belongs to this, hence this is also the final state. That is also the final state. And the PQR, you know that is the initial state. Okay. So this is the initial state and this is also the final state. Clear? And if you read A, then if you read A, then also it is staying at the same state PQR only. If you read B also, same state PQR only. And if you read C also, it is staying in the same state PQR only. Means the figure is A, B, C, right? Not PQR, that is A, B and C. Okay, we can write A or B or C. Okay, that is your desired DFA. Is it clear to everyone? So here you need to remember one thing. Whether the diagram is, question it is mentioned epsilon NFA to NFA or epsilon NFA to DFA. If it is asking epsilon NFA to NFA, then you need to take all the states with you need to find out the epsilon closure of all the state with different inputs. Okay, how many inputs it has used inside the diagram, you need to consider all every input. But if it is asking epsilon NFA to DFA, then you need to consider the epsilon closure of the initial state as the initial state for the DFA diagram also. Okay, now we'll move to the next question. So next question is, consider the following DFA, find the minimized version of the DFA. You know that you can minimize the DFA in two ways, right? One is by considering equivalence state group, and second is means state filling method, that is narrowed Mail theorem. Okay, one is equivalence state grouping method, second is state filling method, table filling method, or otherwise you can say one is table partition method, second is table filling method. Clear? So now we will apply table partition method or equivalence set group method to minimize the DFA. Clear? So in this method, first what we will do, so how many means states are there, based upon their final state and non-final state category means criteria, you divide to them into two categories. One category will belong to final state and second category will belong to non-final state. Okay, so inside the means transition table, you know that the states, those are marked with star mark, these are the final states. Means C, D and E are the final state. Okay. So we will write one first category as final state category, that is CD, and second category as non-final state, that is the rest states. Okay, A, B, C, D, E, then F, G, and H. Clear? So we will make them two categories. Then what we will do? So now we will try to break to the group by considering the equivalent state method. Okay, equivalent state means what? If by consuming input terminal on different states, if all the states are moving to a particular group, then we can say all the states are into one group. Okay, for example, on if you apply A on C, you are moving A. Similarly, if you apply A on D, you are moving to B. Means AB belongs to second group. So you can say that CD both are equivalents. Why? Because by consuming A on CD, you are moving to a same group, right? Now we'll check among CD whether they all are equivalent or different. So first we will break it. Take a transition table. So this is 0, then 1. Okay. So here C, D, and E. Over on C on 0. C0, where you are moving? C0, you are moving to D. And D is in first group, right? So write first group here. Then C on 1, it is moving to B. B is in second group, right? So write 2 here. Similarly, D on 0, it is moving to D, and D is at first group. Clear? Similarly, D on 1, it is moving to A, right? D on 1, it is moving to A. A is in second group. Clear? Now, E on 0, it is moving to D. So D is in first group, so that will become 1. And E on 1, it is moving to F. F is in the second group. So put 2 here. So now you can check, now you can observe here. On CDE, if you consume 0, it is always moving to the first group. Similarly, on CDE, if you consume 1, it is always moving to the second group. Means C, D, and E, all three states are equivalent. Clear? So we cannot break to them into different groups. Now we'll try for second group. So second group is, just write the transition table. This is 0, then 1. Here A, then B, then F, G, H. Okay, now check. A on 0 is B. B is in which group? Second group. So write 2 here. Then A on 1 is that is A, means A is in second group only. So write 2 here. Similarly, B on 0, it is moving A is in second group. Similarly, B on 1 is C is in first group, right? So that is in first group. Like this, you fill up the values. If you fill the values, you will get here, that is 2, and this is 1, and this is 2 2, second group, you just do it, and this is second group and first group. Why? Because H on 1, that is D, and D is in first group. Hope everybody understood. Now if you see from this table, we can observe that A, G are one group, so we'll make them into one group. Why one group? See, both on A and G, if you consume 0, they are moving to second group, and if you consume 1, they are also moving to second group. But B, F and H, they are another group. So group 4 is B, F and H. Clear? Now we'll check for AG. Clear? So take the transition table for AG. So this is A and this is G, and 0, then 1. Okay, A on 0, check it, A on 0, it is moving to B, and B is in which group? That is fourth group. Okay, you should not write again 2 because second group already divided. So A on 0, that is B, and B is in fourth group. Similarly, A on 1, that is A, and A is in third group, means you should write here 3. Clear? Now G on G, G on 0, G on 0, it is moving to F. F is in fourth group, right? Similarly, G on 1, it is moving to G, means G is in third group. Clear? Now you can observe both A and G, by consuming 0 and 1, they are moving to the same group only. Hence, you cannot divide to them into further groups. Okay? Now we'll check for B, F, H. Zero, 1, and here B, F and H. Clear? So B on 0, just check it, B on 0, it is moving to A. A means which group? Third group, right? So write here 3. Then B on 1, it is moving to C. C is in which group? That is first group. Okay? So C here, first group is C, D, E, right? So we will write here 1. Then F on 0, it is moving to G, and G is in which group? Third group, right? So we will write here 3. Similarly, F on 1, it is moving to E, and E is also in the first group. Clear? Now, H on 0, just check it, H on 0 is G. From the table I am just finding, okay? So see here, H on 0, that is G. So G is in which group? That is third group, right? So see here, G is in third group. So write here 3. Then H on 1, that is moving to D, and D is in first group, right? Now you can observe all three B, F and H are also moving the same group after consuming the input 0 and 1. Means further you cannot divide B, F and H also. Clear? Now we will design the transition diagram by considering the final combination of groups. Okay? So one group is CDE. We'll write here CDE. And you know that these are the final states. So we have to mark them into final state. Clear? Then next is AG. Okay, then next is BFH. BFH. B, F and H. That is one group. Okay, now so just draw the transitions. A on 0, that is B, means we can move to that is 0. Similarly, A on 1, that is A. A on 1, that is A, means self loop. Clear? Now G on 0, G on 0 is F, F is also this group, and G on 1, that is G, that is self loop. Hope everybody understood. Then A on 1, that is A, over. AG group is over. Now BFH will check. B on 0, that is A, means if you consume 0, it is coming to this state. Similarly, B on 1, that is C. So if you consume 1 on this state, then you are moving to this state. Over. Then next CD, C on 0, that is D, and D on 0, that is D, and E on 0, that is also D. Means if you consume 0, you will stay in the same state. That is 0. Similarly, check for C. C1 is B, means if you read 1 on this state, then you will move to this state. Clear? So this is your final DFA diagram. Now is it clear? Is it audible? Yes. I am checking the messages. Anything doubt here? If you have any doubt, you just write it down. Yes, you can check. D on 1 is D on 1 is A, right? Or whether we did any mistake here, then C on 1, that is B, correct. C on 1, B, but D on 1, A. C on 1 is B, and D on 1, that is D on 1, that is A. So just we'll check here CD, anything mistake here. So that table you just check. Table correct only na? C C0, that is D. D is 1. C1 is B. B is 2. Okay. D0. D0 is D. That is 1. And D1 is A. That is 2. Similarly, E0 is D. D is 1. Yes. Then E1 is F. F is 2. Okay, correct only. CD. So, so what we'll do, first check here that yes, yes, yes. Okay, something may be wrong there. Due to this, it is not coming. So in the transition diagram, so there is a rule. If the the state is not reachable from the initial state, at first we can remove that particular state from the transition table. That we need to check here. So whether all the states are reachable from the initial state or not. If all the states are reachable, then we can consider like this. If all the states are not reachable from the initial state, we should first remove to that state. Clear? So that we need to check here. A to B, then B to C, C to D, then D to D, D to A, D to A. So you just what you will do, you just draw the transition diagram from the transition table. If you draw the transition diagram, then it will become more clear. So do one thing here. Already we have done this. So first you draw the transition diagram, then check, okay, whether any state is not reachable from the initial state. So find it first. If any state is not reachable from the initial state, just first remove to that state from the transition diagram. Then after that you process it. Clear? So that step I didn't follow here. So you first do it, then you process it so that you can get the answer. Okay. Now I cannot do it because it will take more time. So you first do, if a state is not reachable from the initial state, first remove it from the transition diagram. Then you process like this. Clear? Then next question we will see, consider the following DFA and find the corresponding regular expression. I am just waiting. Can anybody tell what is the regular expression for it? So Just tell me the regular expression. How will you process? Find out from for all states the reachable states. Clear? For all states, reachable states, you just find out. And for initial state, you need to consider the epsilon transition also, because by considering epsilon, you can reach to the initial state. You can assume like this. Clear? So for initial state, we will write. So what is our initial state? 1, right? So 1 equals to, we can write, for overcoming the confusion, I am writing that is Q1. Q1, okay? So just take it Q1, Q2, Q3. Q1 equals to epsilon plus what we can write? Q2 1, Q2 0, right? Q2 0. Similarly, Q2 equals to, we can write Q1 1. Okay? Similarly, we can write Q3 equals to Q1 0 plus Q2 1 plus Q3 0 plus Q3 1. Isn't it? So see to the diagram, onto a particular state, from which state you are coming, that you write. Clear? So on Q3 you can reach from Q1 as well as Q2 as well as Q3. So that's why I wrote there Q3 equal to Q1 0 plus Q2 1 plus Q3 0 plus Q3 1. Q3 0, Q3 1 is that loop, self loop it is taking, right? Hence I wrote there. Now, though Q3 is the final state, so what you will find out the regular expression for Q3. Yes or no? So what we will do? First take Q1 1, okay, and apply it on Q1. So Q1 equals to, we can write epsilon plus Q2 0, right? Q2 0. Then that we can write epsilon plus Q1 1 then 0. Because Q2 equal to Q1 1, right? So we can write epsilon plus Q1 1 0. That we can write as 1 0 star. Why 1 0 star? As per the rule of R equal to QP star. R equals to QP star. Clear? Here this is your P and Q1 is your R. Hope everybody understood. Now put that Q1 value on Q2. So now we can write Q2 equals to Q1 1 equals to Q1 equal to how much you got? 1 0 star you got. So we can write 1 0 star into 1. Clear? Okay, then so that Q2 value now you apply, you put in Q3. So Q3 equals to, we can write Q10 means Q1 equal to how much you got? That is 10 star, right? So we'll write 10 star, then 0. After that plus Q21. Q21 means 10 star, then 1 1, clear, plus, that is Q3 0 and Q3 1. So that value we can write Q3 0 plus 1, right? This is, we can write Q3 0 plus 1. So here we can write also Q3 0 plus 1. Clear? Now if you solve this, so what you will get? You will take this term, the first two terms are single factor, that is Q, and Q3 0 plus 1, that is RP. Clear? So we'll write 10 star, 10 star into 0 plus 1 into 10 star into 1. Okay, that is one category, one part, that is Q, and this part is Q3 0 plus 1. Clear? And that is in the form of RP, right? This is RP. So what is P? P is 0 plus 1. So that we can write QP star. This is your Q, this is your Q, and this is RP. So now we can write Q3 equals to, Q3 equals to 10 star, 10 star 0 plus 1 into 0 1 star into 1. Clear? That is one part. Then 0 plus 1 star. Okay? So this is the final answer. Now we move to the question number 5. So in question number 5, it is saying that find the regular expression for the language L equals to set of odd number of A followed by any number of B's followed by any number of C's. Sir, how 0 1? Oh, 01. It is not visible, Babu. Can you write your question again? 1146. Can you write your question again? Your message is not clear to me. Okay. So let's move to the fifth question A. Here it is saying that number of A's should be odd and it is followed by any number of B's and any number of C's. Clear? Means the string may be A, B, C, isn't it? Here number of A is 1 means it is odd, and the string may be also A, the string may be also AB, okay, but the string BC is not acceptable. Clear? Because here A is not present. Yes or no? And similarly, the string AA, BC, that is also not acceptable. Why? Because the number of A's are 2 here. 10 star 0 plus 101 star 1 and 0 plus 1 star. Yes, that only came, na? That is the answer came. Babu, 01 and 10 both are same. R1, R2 as per the means rule, R1, R2 equals to R2, R1. When you are multiplying that 0 on the state, that I think Q0, you are multiplying that Q2 value you are putting on Q1. At that time, in place of 10 you write it 01, so you will get the answer. Okay. Now, if you will draw the diagram for this, you will get Q0, Q0 to 0, Q0, then A, you will get Q1, and Q1 is your final state. Yes or no? Because A is a single state and single A is an means your odd number of A's, okay? And it is not having any B character and C character, so it is a final state. Similarly, A to B, that is also a final state. This is Q2 state and this will also become a final state, isn't it? Why? Because AB is also acceptable, right? And in AB, the number of A is odd, hence it is also final state. Similarly, if you move ABC, if you read C, then you will get the string as ABC, isn't it? So, Q3 will also become final state. Hope it is clear. But if you read another A on Q1, if you read another A on Q1, then number of A's will become 2, right? And it is an even number of A's. Hence, it should move to the non-final state. Clear? If you read A on Q1, 1 minute. Okay, that will move to Q0 and it is a non-final state. But if you write 3s, see here Q0 to Q1a, Q1 to Q0a, again Q0 to Q1a, means number of a's are 3. Hence, it will move to the final state. Okay. Then Q3 to Q1 to Q3 will make any C transaction. Clear? And here on Q2 you can read any number of B's, right? And on C also you can read any number of C's, because it is followed by any number of B's and any number of C's. That is your final diagram. Clear? And for this diagram you can design a DFA, but I think it is satisfying DFA Q0 A, but it is not satisfying B. Okay, BC. So what you will do, take a dummy state, but it is asking regular expression, right? So what is the regular expression you can write? That is A, then A star. Why I wrote A star? Because if you write single A star result you can also single get single A also you can result. So if you take single A, that is A, previously one A is there, and with A that will call means coming under the even number of A's, and it is not acceptable. Clear? So A star, then B star, then C star. Yes. No gamer. That is correct. You are correct. So now we'll move to the next question. That is the last question. Convert the following regular expression into finite automata. So what you will do? Take Q0. On Q0 read 0 plus 1. Zero plus 1, that is Q2, sorry Q1. Then on Q1 read 0, you will go to Q2. Then on Q2 you can read any number of zeros, right? So that's why that is 0. Over. Similarly, 0 star is over, then we will take 1. So Q2, 1, Q3. Then on Q3 read 0. You will move to Q4. Okay. And on Q4 you read 1 to move Q5. And Q5 is your final state. And on Q5 you can make a self loop at 0, sorry 1, because it is 1 star, right? So make Q5 as final state. Clear? This is your NFA. Now if we will design the DFA, So here we can break to that 0 plus 1. If you break to that 0 plus 1, the figure will come like this. So Q0, then Q1, Q0 to 0, Q1, and Q0 to 1, Q1. Okay, this is 0, upper part is 0, lower part is 1. Over, then Q1 to 0, Q2, and on Q2 you take a self loop as 0, and on Q2 read 1, then you will move to Q3, on Q3 read 0, you will move to Q4, then on Q4 if you read 1, then it will move to Q5. And make Q5 as the final state. Okay, then now what we will do, so this is your NFA. Now we'll take a dummy state to satisfy to this string as a DFA. So take a dummy state QD here. Okay, so for this transition table, first you will draw that for this transition diagram, first you will draw the transition table, then the transition table you convert to the self loop on Q1 is enough for 0 star. Yes, no problem. Yes, Babu, you can take on 0 star on Q1. Similarly, you can take 1 star on Q4 also. Self loop on Q4 also 1 star you can take. No problem. So Q1 1, you need to move to the dummy state. If it is asking NFA, you can stop there. But if it is asking DFA, you need to design a DFA for this. This is 1. Similarly, Q3, Q2 0 1 completed. Q3 0 is there, but 1 you need to draw. That is 1. Similarly, Q4 1 completed. You need to design. That is 0. Okay. Then Q5, it is taking self loop 1. So you need to consume 0 transition Q5 to QD. Okay, then here you need to write zero transition. That is your final figure. So the above part is your NFA and lower part is your DFA. Okay. So with this, I think everybody clear about this. This question carries 7 mark. This question carries 7 mark. The first question carries 3 mark. Here you need to draw the transition table. Okay. For NFA you need to draw the transition table. Then from the NFA transition table to you need to convert DFA transition table. The procedure is the first transition of NFA transition table will remain same in DFA transition table, and by taking the new state you will continue in the DFA transition table. But it is directly figure, it is given, no need to draw, just you can draw it. Okay. So thank you students. Still if you have any doubt regarding this, any question, because so due to some internet issue it is lagging. So if you are having any doubt, any question on any question, just post a message on the comment section so that I will give the solution for it. Thank you.